Okay, so find the sum of the first 12 terms of the series in which the first term is a 7 and the common ratio is a 5.
Wait a minute. I still have to finish the sum of secret equation.
So we have our formula.
Oh, what? Oh, it's right there. I found it, guys. Don't worry.
So this is our formula. So let's write down all the variables. See what we know and what we need to know. So what do we know?
There's 12 terms.
Okay, we know that there's 12 terms, so what does that tell us?
N.
Good, n is 12.
And it's 12.
So this is the sum of the first 12 terms, right?
Yeah.
That's what we're looking for.
First term 7.
The first term is 7. First term is 7.
Wait.
Common ratio is 5. So now just use the formula. The sum of those 12 terms is equal to the first term times 1 minus the common ratio to the nth power, which is 12, divided by 1 minus the common ratio. So 5 to the 12th power,
It's a lot.
that's a big, huge number.
Yeah.
Okay, if I subtract that from 1, then multiply by 7, then divide by -4, I'm going to get 427,246,092. Now I realize that number's huge, but think about what that geometric series looks like. It's 7, then I multiply 5 to get 35, then I multiply that by 5 to get 175, then I multiply that by 5 to get 875, then I multiply that by 5 to get 4,375, and so on and so on. I do that for 12 terms, then I add all that together. So you can see why it would be big, because that is an exponential that's going to grow really fast.
So
Remember that if you multiply by 2, multiplying by 2 look like this, right? So multiplying by 5 is going to grow even faster. So that is a reasonable answer. Now we're going to talk about sigma notation and how that affects what we're doing. Now the pieces and parts of this are very similar to what we did with the arithmetic. Okay, so it's going to feel familiar. Remember that sigma notation is a shortcut way to write a series. It's a faster way to write it down. But you have to be able to interpret what it means.
Right, that's the problem.
All right, so.
Is that 3 times?
Yes, that's a multiplication. All right, so here's the formula I'm going to use. So, first of all, what is n?
So, Mr. You use that formula every single time?
For sum, if you're adding them up. And that's what this
What
means,
were you
sum.
adding? Okay. But you did the sum on the last equation you just did. It didn't happen.
Correct. Yeah, because I was still adding them up. This is a different way to write that. This is sigma notation. It's just a different way to write the same. Instead of writing it all out in words, I could write it like that. Okay. So what did you say n was?
8.
Not 8.
I said 1, but
It's not 1. N is the number of terms. So how many terms are there if there's starts at 1 and goes to 7? Oop. 1, 2, 3, 4, 5, 6, 7. 7. Okay? Now, what's the first term? The first term is what I get when I put this number in here, right?
14.
3 times 5 to the 1 minus 1 power. So that's 3 times 5 to the 0 power, which is, that's a 1. So that's 3. Okay, what else do I need to know? I got n, I got a sub 1. The common ratio, yeah. How can I find the common ratio?
Well, you stick that K in, right? Don't you? Look, look, so K equals 1, don't you put the 1 in K?
And that's what we did here when we got the first term.
Right, but, oh yeah.
Okay, so how do you find the common ratio?
Don't you divide the first term by the second?
You divide the second term by the first term. We have the first
So
term.
you stick in the second term for K, and then that's how you.
Okay, so if I found the second term, I could divide those two?
Uh-huh.
All right?
5 times
Okay, so 2 minus 1, that's 3 times 5 to the first power is 15. So the common ratio is 15 divided by 3, which is, that's interesting.